Welcome to ICN Sunday Morning. I'm Vernon Loeb, Executive Editor. We learned last week from a series of climate reports that the planet in 2025 experienced an unprecedented run of global heat. 10 years after the 2015 Paris Climate Accord, which sought to limit warming to 1.5 degrees Celsius above pre-industrial levels, human-caused emissions have not gone down as fast as people who wrote the Paris Accord thought they would. In fact, they've continued to go up. In other words, the world's governments are failing to adequately address the threats posed by climate change. Joining me to talk about this morning is Bob Berwyn, our science correspondent, who also covers the UN's Intergovernmental Panel on Climate Change. Bob, thanks for joining me.
Nice to be here.
So, I think a lot of people are a little bit fooled when we talk about 1.5 degrees warming. It doesn't sound like that big a deal, right? But 1.5 degrees is a global average, and that average hides massive inequalities around the planet. Um, a small shift in the global average from 1.5 degrees to 1.7 degrees brings about an enormous increase in extreme hurricane, extreme drought, extreme heat waves. Um, I think that's important, for people to get their minds around what we're really talking about here. We spend a lot of time, I think, sometimes covering climate, missing the forest for the trees. And this is the forest, the warming of the planet. So what's this unprecedented run of global heat all about? Explain to us what that means.
Yeah, absolutely. One thing to your initial comment, one thing that helps me understand this matter of how serious 1.5 degrees is. The heating over land, for example, is twice the global average. So in effect, land areas already, much warmer than that 1.5 degrees, closer to 3 degrees Celsius or nearly 6 degrees Fahrenheit since the early 1900s. And that is enough of a shift that scientists say that this is taking us out of a safe climate that provided for human development, that sustained ecosystems and food systems that we've relied on for thousands of years now. So it is a significant shift. And these reports that came out altogether, all are in complete agreement that the last 3 years have been, I hate to use this cliche, but off the charts. They're saying, okay, we've taken another step up. We've had 3 years where the temperatures have been sort of above this limit set by the Paris Agreement, and it doesn't look like it's going back. There's no reason to think that. The science doesn't suggest that. And the director of Copernicus, the European Climate Change Service, said, even if it may seem unexpected, based on the physics, it's not, because we haven't reduced greenhouse gas emissions at the rate that we thought we would when the Paris Agreement was signed. So we've
Yeah.
had 3 years now where the temperature has been above or right at that 1.5 degree mark, and the 3 years average together puts it above that. So
Yeah.
it's definitely sort of a threshold that we've crossed.
And that's really significant. We've been continuing to talk about 1.5 degrees warming as an achievable goal. But what you're saying now is basically if you look at those 3 years together, that we're past 1.5 degrees.
I would say so. In practical terms, we are past it. There's a
Yeah.
theoretical world of climate models where if emissions start dropping this year by 7% a year, global emissions, and we find a way to take carbon dioxide out of the atmosphere in large quantities, that the temperature could stabilize at around 1.5 after going above it by the end of the century. But that increasingly is a very theoretical world.
Yeah.
That threshold is not just symbolic, it's tied to real physical risks, as was highlighted by the IPCC a few years after Paris, when they looked at what happens specifically when the average global temperature goes above that. Again, you have more heating over land, so you lose glaciers, you start to lose ice faster. It's pretty clear that that's a threshold for almost all coral reef systems and glaciers, that beyond that, hardly any of them will survive even to the end of the century. So
Yeah.
it's serious.
Yeah. It's interesting to me how alarmed climate scientists are by the speed with which we're warming.
Yes. Um, there still seems to be some argument over if there's a long-term acceleration or not. But again, I think you have to see this over a global scale and over a long term. And if you look at it, break it down by decades, every decade, of the last 100 years has been warmer than the previous decade, and the last 2 decades have soared even above those, that more gradual rate of increase. So I don't
Yeah.
I don't think there's a huge question that it's accelerating. Maybe the degree to which it's speeding up is still in question.
Yeah. Yeah. And we're really sort of in uncharted territory. We're starting to get the temperature levels where we've never been before, and the scientists really don't even know what's possible at that point.
Well, I think they have some inkling, but I think they're also finding out new things. Climate science isn't static; it's constantly advancing. There are new studies coming out every day that advance knowledge of different topics. And as you know, for the last few years, there's been a real focus on this Atlantic heat transporting system that distributes heat between the northern hemisphere and cold between the southern hemisphere. And there's a real outcry now scientifically about, whoa, we are getting closer to understanding how close that part of the climate is to collapsing.
Hmm. So how dire are things based on these three reports or three or four reports that came out this week? In your piece, you quoted some projections from James Hansen, the famous NASA scientist who first testified before Congress about the threat of climate change back in the 80s, was it?
Yes.
He's predicting that we could be at 1.7 degrees by 2027 with a new warming El Nino.
Hmm. He didn't make a hard and fast prediction, but he's suspecting that if we have another moderate to strong El Nino, whether it's this year or next year, then the subsequent year could easily get toward 1.7 degrees. And
Yeah,
from my reading of his papers, then you're getting to a level that's not only dangerous, but potentially structurally destabilizing, that just threatens all sorts of human systems and natural systems. He points out that that's not just a bit hotter, it pushes systems toward collapse, toward irrevocable change, so that they go from one state to another, having glaciers, not having glaciers, having sea ice, not having sea ice.
right. And it gets back to the point we made earlier. There's a big difference between 1.5 degrees and 1.7 degrees. Doesn't
Yeah.
sound like much, but it's a global average and it's masking these huge inequalities in temperature.
Yeah, it's not a temporary fever. It's a dangerous chronic condition, and we keep adding fuel to the fire by continuing to burn fossil fuels and destroy forests and emit greenhouse gases.
Right. And as emissions grow, they trigger feedback loops that add to warming separate and apart from emissions. Explain to us how the feedback loops work, say, at the Arctic.
Certainly. The all these major global climate reports that just came out all emphasized warmest ever conditions or close to at both poles and continued amplification of Arctic warming, which means the Arctic is also warming much faster than the rest. And in the Arctic, feedback loops mean things like when sea ice melts, the darker colored oceans absorb more sun, which then heats the air above it and leads to more melting. You get thawing permafrost, which releases methane, which traps more heat and also increases warming again. So, those are some of the easiest or clearest feedback loops to understand. And so we're not just turning up the thermostat, we're kind of supercharging the furnace now, and it's
Yeah,
getting out
yeah.
of control.
Yeah, another really fascinating point you made in your piece was that given the new warming and the emissions increases, uh, climate change is no longer just an emissions problem, but it's a problem besetting the world's electric grids and the world's
Yes.
electric machinery.
Yeah.
Uh, Explain that.
Sure. I think what they were trying to point out is that it's not just a problem of temperatures and greenhouse gas concentrations or pollution anymore. It's about the threats to the systems that sustain us. And energy systems obviously are crucial to that. So, this report from the WMO pointed out that climate change presents sort of a day-to-day operational problem for power grids and for operators. Fluctuations in extremes, some of the unexpected things that we talked about, perhaps shifts in wind patterns. It's sort of warming colliding with the basic machinery of modern life. And a couple of specific examples, heat waves are now a primary driver of peak electricity demand. And you have these kind of compounding effects where you have cooling demand growing the fastest where grids are the weakest. Droughts cutting the ability to create hydropower right when heat boosts the demand for that power. And the report gets into a bit of detail about wind and solar becoming more regionally volatile and creating supply and demand mismatches. So, in places where maybe expected wind patterns are shifting and people had planned to be able to supply the grid from that area, now they're going, wait, we might have to rethink this. And these uncertainties about what the climate's going to do in the next 20 to 30 years, say the lifespan of a solar farm, um, that's exactly overlaps with what we're talking about here. So it's very challenging, and it's sure to become more challenging.
Yeah, and if you look at the grid upgrades taking place in the US right now and all the data centers we're building, primarily to power AI, um, the data centers are almost, which use enormous amounts of electricity. They're almost their own feedback loop, right? You build these data centers, and unless you power them with renewable energy, and many of them are not being powered, but Trump wants to power them all, of course, with fossil fuels. That then
Yeah,
becomes a feedback loop. The data centers are an
yeah,
incredible climate bomb.
yeah, yeah. I think it's sort of a type of feedback loop, or maybe something like an escalating demand spiral. I'm a little careful with using feedbacks when I'm talking about climate to be really clear that we're talking about real specific physical processes in the climate system. But there are other types of human action feedback loops too. And clearly, if you create this huge new demand for power and you use fossil fuels to generate that power, you're going to have even more warming. So it is,
Yeah.
yeah.
I was struck by a quote in your piece from Carlo Bontempo, the director of the Copernicus Climate Change Service, who said, "It's up to us to decide how we want to deal with the higher risks that we'll face as a consequence of this warming." And and that sort of brought it home to me. What we're faced with right now are higher risks in the future.
Hmm.
And I think you noted what, $23 billion calamities in the US in 2025.
Yes, there was another report out independent of the global climate reports that went through the same data that the federal government used to use before the Trump administration. And Looked at all these climate related events and it was one of the top 2 or 3 years, I think, for these billion-dollar disasters. So individual events, flooding or tropical storms that just cause huge amounts of not just economic damage, but physical dislocation for people, disruptions of people's lives, deaths, and lots of long-term post-traumatic effects too to people that they live with in some cases the rest of their lives. So it's all these impacts are hugely disruptive to societies and becoming more so. I don't think scientists are arguing about whether it's dangerous anymore. They're sort of getting back to what you mentioned. We're starting to discuss how much risk we can live with and how we're going to try and handle and manage that risk from the threats that we know are coming.
Yeah, yeah. Bob, thanks so much for being here.
You're welcome, Vernon.
Yeah. And thanks to all of you for reading our work and watching, and of course, for all the support you give us throughout the year.